All right. So this whole unit is going to be on simplifying different kinds of radicals. Okay. So first, if we're going to label kind of the different parts. The first part is this guy out in front of here is called the index. Okay. And most of the time, you guys are going to see square roots that look like that, right? And cube roots, which look like that with a 3 in front of it. Okay? That number that's out in front is a 3. Okay? If there's not a number out in front right here, okay, we are going to assume that it's a 2. Okay? Because if there's not one out there, what do we call this? Square root, right? And if I square a number, it's what exponent? 2, yeah. So that's an imaginary 2 out there. Okay? This symbol is called the radical. Okay? And the number that's underneath it is called the radicand. All right, so our perfect squares. What a perfect square is a number that you can take the square root of and get a whole number. Okay? My first one is always going to be 1, because the square root of 1 is 1. Okay, so that's our first square root. Okay, our second square root would be, oh, careful, square root of 2 is what? 4. So, well, no, that's not it. 2 squared is 4, but what's the square root of 2? It's some random decimal, right? So what number can I take the square root of? 4. There you go. 4 is our next one. Okay? And how did we get to 4? We took what and squared it? 2. Yep. And then the square root of 4 is 2. Okay? So my next one is going to be 3 squared, which is 9. Okay, because 3 squared is 9, so the square root of 9 is 3. Okay, so next one, 16. This 4 squared gives us 16, so square root of 16 is 4. Okay, what's next? 25. Square root of 25 is 5. What's next? 36. Square root of 36 is 6. 49 would be next. Then 64. 81. 100. 121 and 144. Okay? You are going to have to learn and memorize the first 12 square roots. Okay, or the first 12 perfect squares. By the time you get to algebra 2, you're going to have to know all 20 of them. Okay, the first 20, but for right now, we're going first 12. Alright, so far so good? Alright, so what's the square root of 16? 4. Okay, now, this number out in front needs to do what? Times. So 2 times, what's the square root of 121? 11, which is 22. Okay, and then we have 6 times, who can tell me that one? 17 gives us 20, what? 102, thank you. Okay, and then 3 times square root of 400, 20, gives us 6. All right, now for the hard part. Okay, simplifying square roots is kind of like putting fractions in lowest terms. Okay, there's still going to be a square root hooked onto it, but we're going to simplify it to the lowest we can get it. Okay, so what we need we need to figure out what the factors of 32 are. Okay? What times what gives me 32? 1 times 32, what else? 8 times 4, what else? 16 times 2, anything else? Alright, so these numbers are paired up like that, right? Okay. Which pairs have perfect squares in them? Okay, and we're not going to ever count 1, so that's up. 16 and 2 has a perfect square. 16 is a perfect square. Does 8 and 4 have a perfect square? Yeah, because 4 is a perfect square. So they both have perfect squares. But what you want to pick is you want to pick the pair that has the biggest perfect square. So my biggest perfect square out of these two is 16. So I'm going to split this now into 2 square roots. I'm going to split it into the square root of 16 and the square root of 2. So 16 times 2 gives me 32. Okay. Now I can simplify the perfect square. What's the square root of 16? So 4 root 2 is my answer. Okay, because I can't simplify root 2 without any further, can I? Okay, so now I'm done because I can't simplify the square root of 2. Okay, so we need some factors of 180. Okay, but we're going to ignore the 1 and 180. We're going to always ignore that first one. What is it, 90 and 2? All right. 60 and 3? 45 and 4. What else? Keep it coming. 36 times 5. All right, so now I've got some pairs. Which one has a perfect square in it? The 36 times 5. So that's what I'm going to split this into. Square root of 36. Square root of 5. What is my square root of 36? 6 root 5 is my answer. Okay, this section isn't going to be super easy. I realize that. Okay, so finding factors of 147. 3 and what? Alright, so let's stop right there. Is that a perfect square? Boom. Okay, we can use it. Okay, so I'm going to write this as what? Well, no, not 49 squared. Square root of 49. Yep, so let's talk about that. Let's make sure that we're always saying either square root or root. Okay? So we gotta be careful with our vocabulary as far as that goes. So my square root of 49 is 7 root 3. Okay? So factors of 175 we should be trying to figure out right now. 35 and 5? No. What? Okay, so 35 and 5 are those. Is that, do I have perfect squares? No? So what else? Alright, 25 and 7. Do I have a perfect square? Yep, so let's write those guys. Square root of 25. Square root of 7. So my square root of 25 is 5 root 7. Okay, so everybody, without yelling it out, I want you to try to do 48 on your paper right now. what did you use? Okay, so right here, 12 and 4. Okay, so let's talk about that. Okay, I can go square root of 4, square root of 12, right? What's my square root of 4? 2 root 12. Now, let's talk about this, because I have root 12, right? Can I reduce root 12 at all? I can reduce my root 12, so I have 2 times. What can root 12 go into? Root. Okay, 2 and 6, what are those perfect squares? No, so what else? Yeah, 4 and 3, right? So 2 times, what's the square root of 4? 2 root 3. 2 times 2 is? So 4 root 3. Alright, so that's one way. Did anybody else use a different factor? Yeah? Alright, so now I'm hearing square root of 16, square root of 3. Okay, what's my square root of 16? So 4 root 3. Did we get the same answer? Yes. Yes. Which way was faster? The 16 and 3. So either way works. Okay, but it helps. Okay, it's a lot shorter process if you pick the biggest perfect square that goes into that. Should I have a question?
What situation does it have to use this?
This is if we want like an exact answer. We use it a lot in geometry. Okay, when we don't want anything rounded, we do it in terms of square roots. Okay. All right, so when we are doing number 10, I want you to ignore the 2 out in front. Okay, and just reduce the square root of 54. Trev, what did you use?
I used 96.
All right, so Trev used 9 and 6. So square root of 9, square root of 6, what's my square root of 9? So 3 root 6. Can I reduce that 6 at all? No. You can, okay, so some of us are saying yes, and I agree that that can be reduced into 2 and 3, right? But is 2 and 3 perfect squares? No, so I'm done right here. Okay, does that make sense? Alright, so number 11 we can ignore. We're gonna, on these 4, we're gonna ignore the numbers in front right now. Okay, so we're all working on these 4 right now. Okay, sometimes it helps to have those perfect squares in front of you. Okay, so sometimes when I'm struggling with what I want to use as a perfect square, I start dividing by these numbers. So since it's a big number like 150, I might try to divide it by 49 and see if I get a whole number. Then I'll try to divide it by 36 to see if I get a whole number. Then I'll divide it by 25. Did any of those work to divide and get a whole number? The 25 did, alright. So then we can use the square root of 25. And when I divided 150 by 25, what did I get? 6. So I can use the square root of 25 and the square root of 6. What's the square root of 25? So 5 root of 6. Okay. sure, have you found one for 128 yet? 64 and 2? Alright. That's a nice big one. 64 square root of 2. And can I reduce that square root of 2? Oh, so I'm good. So what's my square root of 64? 8 root 2. Did anybody else try to use something smaller? So I think 4 works. I think 16 might work. Okay, what'd you use, Lisa? 4? And 32, alright. So if I go square root of 4, square root of 32, so now what's my square root of 4? 2 root 32, right? But can I reduce my 32 now? No. Okay, you've always got to check this to see if something goes into it. So 32 can be what and what? But we can still do it this way. Yeah, so now we're 16 and 2. So 2 times 4 root 2, so what's 2 times 4? So 8 root 2. So did we still get to the same answer? Yep, we just had to take an extra step, right? Okay, but we're always trying to look for our biggest one. It'll save us some time. John C, are you done with 28? What'd you get? Are you still working on it? 4 and 7, okay. So root 4, root 7. Can I reduce that root 7? No? So 2, root 7, we're good. Alright, 384 is a little bigger one. Skylar, what did you do for 384? 64 and 6? Alright, square root of 64, square root of 6, we get it. 8 root of 6. Did anybody go smaller and have to do it twice? Okay, if you did, that's okay. Did you get to that same answer? What did you start with? Alright, so 384. We went square root of 16, square root of what? 24. Okay, so we've got 4 root 24. Okay, so now we're looking at that root 24. What can I reduce that to? Square root of 4, square root of 6, right? So 4 times, what's my square root of 4? 2 square root of 6. So out front, my 4 times my 2? 8 root 6.
Oh, I just had like 4 times 6.
Oh, careful, because it's square root of 4, square root of 6. Because you're splitting that square root of 24.
Oh, okay.
Okay, does that make sense?
Yeah.
Perfect. Okay, they start